In this video, I'm going to focus on the law of conservation of momentum, both with what the law is and with when to apply it. Let's start with the law itself. It states that if no external forces are present to affect the colliding objects, then the total momentum before the collision will be equal to the total momentum after the collision. In equation form, the law looks like this. Pi represents initial momentum, Pf represents final momentum. I like to think of the equal sign as where the collision occurs, so anything that occurred before the collision would go on the left side, and anything after the collision on the right side. The goal of this video is to use the external force part of the definition up here as a means of discussing when the conservation should be applied and also when it should not. To differentiate between forces as being internal or external, let's review our mechanical system. This is made up of three things. That would be the objects in question, or in this case the colliding objects, the planet that the collision occurs on, most often Earth, and any springs in the problem. If the force comes from those three, we classify it as an internal force, and it will not affect the total momentum of the system. If instead the force comes from outside of those three, we would classify it as an external force, and depending on its direction, it could affect the total momentum of the system. Let's look at an example. Before the collision, I have a blue cart moving right and a red cart moving left. They are moving towards each other. After the collision, they have rebounded and now are moving away from each other. Looking at the forces, first on the blue cart, this is during the colliding moment. We have a normal force upward from the surface, a gravitational force downward by the Earth, and a leftward force on the blue cart by the red cart. I'll call this force F object. Looking at forces on the red cart, I have the same two vertical forces, but now a rightward force on the red cart by the blue cart. The goal here is to determine if we can use the law of conservation of momentum. To get there, let's talk through each force as being internal or external. Starting with the gravitational force, this is caused by the Earth. The Earth is part of our mechanical system, and that makes Fg an internal force. It will not affect the total momentum. F object is also by our mechanical system. That would be by the objects themselves. So these two forces will also not affect the total momentum of the system. Normal force is an external force because it's provided by the surface, but look at its direction. This collision occurs along the x-axis, whereas the normal force is directed vertically upward along the y-axis. Because of its direction, this force will not affect the collision, and it will not affect the total momentum of the system. From all of that, we have no external forces that affect our collision, so we would be able to use the law of conservation of momentum for this collision. Let's look at a second example. Here we have a blue cart moving to the right, and it will crash into the stationary red cart. But introduced in this problem is a person's hand, which is resting on top of the red cart and holding it in place. So observe that the blue cart is moving. When it hits the red cart, everything has come to rest. Let's focus on forces on the red cart. We have the same two vertical forces as before. We have a rightward force on the red cart by the blue cart, and we also have a leftward force on the red cart by the person's hand. As the blue cart runs into the red cart, it pushes it to the right, and the hand will resist that and push back to the left. Would momentum be conserved in this collision? Well, again, let's talk through each force as being internal or external to figure that out. Just like in our first example, the gravitational force and the object force are internal to our mechanical system. Also, the normal force is still perpendicular to our colliding plane. It occurs along the y-axis, while our collision occurs along the x-axis. So for the same three reasons as last time, these forces will not affect the conservation of momentum. But now we have a fourth force to deal with. This is on the red cart by the person's hand. The person's hand is external to our mechanical system, and the direction of this force is clearly along the x-axis, the same axis that the collision occurs along. So we would say that this force does affect the conservation of momentum, and we would not want to use our law. Look at the blue cart specifically. It had momentum because it has a mass and a velocity initially. At the end, everything has come to rest, so nothing has momentum. That's a clear change from some to none, and the reason it changed is because we have an external force as the cause of that. In summary, if the question is when should the law of conservation of momentum be applied, I think we need to start our answer with a second question. Are there any external forces in the collision? If the answer is no, then you can use the law of conservation of momentum. But if the answer is yes, even one, and it occurs along the colliding plane, you would not want to use the conservation law, and we'd have to go another way.